For the next section, 4.6, graphing the other four trig functions, the work that we do will be the exact same. The only difference is we have to be careful of some asymptotes. And so for the cosecant graph, our important points, our key points that we're going to use, they've given you several here. We're actually not going to use all of them. You're more than welcome to use some of them if you want. The ones that we're going to use for our graphing are actually going to be the same quadrantal angles that we used for sine and cosine. And so we'll use these again. Where these undefineds are, those are going to be your vertical asymptotes. So we'll be able to see where our new vertical asymptotes are. And then the 1 and the -1 will give us our relative maxes and mins. That'll be sufficient information for us to be able to graph these. But if you want to include these other three as well, you're more than welcome to. You don't have to. All right, so there's a couple of things that you have to fill in. First of all, there's no x-intercepts. And then down at the bottom, it says for all x in the domain, if you have a negative angle, it's the same thing as having the negative cosecant of the positive angle. Okay. All right, so secant, same type of thing. We'll use the quadrantal angles for this one as well. So 0, 1, pi over 2, undefined. We'll do pi, 3 pi over 2, and 2 pi as well. Okay? And I'll fill those in when I do a secant graph, which is going to be on our next example. Oh, I lied. It's a cosecant graph. All right. So for this one, it says to graph 2 periods, and then we would use Desmos or a calculator to verify our answers. And so we start off the same exact way. We're going to use our transformations to create our formulas. From those formulas, we will use our parent function points to put through the formulas. And then that'll give us our points that we are going to use. So going left pi over 4 is the same thing as doing x minus pi over 4. Vertically stretching by 2 means take your y values and multiply by 2. This time your parent function is cosecant of x. You might want to also write above that, it's the same thing as 1 over sine of x. And so use your quadrantal angles. You're more than welcome to use extras if you like. And so now I'm going to think about a unit circle. And so I've got 0. The angle 0 has a point at 1, 0. Well, the reciprocal of 0 then, to get cosecant of 0, is going to be 1 over 0. So this is going to be undefined, which is one of those vertical asymptotes is going to be. The same thing will happen at pi because it also has a y value of 0. And back around to 2 pi because it also has a y value of 0. Now when you go straight up to pi over 2, this value is 0, 1 for the point. And 1 is the y value of pi over 2, so if you take the reciprocal of that, cosecant of pi over 2 will also be 1. And then for 3 pi over 2, the point is 0, -1. The y value of 3 pi over 2, which is the sine, is -1. So take the reciprocal of that and you get -1. So when you start subtracting pi over 4 from each of your x's and doubling all of your y's, you'll have your graph that has been transformed. So I'll go ahead and start subtracting these. Pi over 2 minus pi over 4 is the same thing as 2 pi over 4 minus pi over 4. Pi is the same thing as 4 pi over 4 minus the pi over 4 will give me 3 pi over 4. 3 pi over 2 is the same thing as 6 pi over 4 minus pi over 4 is going to be 5 pi over 4. And then 2 pi is the same thing as 8 pi over 4 minus pi over 4 is 7 pi over 4. You can't double a vertical asymptote. That just simply means my vertical asymptote will be at negative pi over 4. There will be another one at 3 pi over 4, and then another one at 7 pi over 4. If I double 1, I'll get 2. Double -1, I'll get -2. So these are the values that I will graph. So my first vertical asymptote, you'll notice that these tick marks, it's really hard to see them, but this would be pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, and 4 pi over 4, which is pi. And so what I'll do now is I'll start putting in my vertical asymptotes. The first one will be at negative pi over 4, which is here. And then positive 3 pi over 4, which is here. And then this is 8 pi over 4 for 2 pi, so 7 pi over 4 would be right before it. So there's my 3 vertical asymptotes. At pi over 4, I wrote pi over 2 here earlier, that's pi over 4. I'll have my relative max or relative min for my cosecant graph, and then 5 pi over 4 comma negative 2. This is 4 pi over 4. So 1 directly to the right of that would be 5 pi over 4. And so I'll make a dot at negative 2. So since these are supposed to be parabolic shapes that are that are pointing upwards and downwards, I'll just simply do my best to create those shapes. They don't have to be beautiful. Use your vertical asymptotes as guides for your arrows. And then because it says to draw more of these, we're going to go ahead and continue. It said to do 2 periods worth. This is only 1 period's worth. So you'll notice that these, to go from negative pi over 4 to 3 pi over 4 is 4 pi over 4 units, and 4 pi over 4 units is the same thing as pi. So my next one will be at negative pi over 4 minus pi units, which is going to be at negative 5 pi over 4. And then in between these two vertical asymptotes, directly in the middle, I'm going to have another portion of a parabola that points downwards for my relative max. And then same thing here, about in the middle of my two vertical asymptotes, I'll have another parabola pointing upwards, and this is sufficient for your graph. Okay, I'll do one more. You've got tangent and cotangent. So cotangent and tangent are going to work similarly to one another. We are not going to use all of the not the quadrantal angles this time. We're actually going to use 0 and pi over 2. We're going to include pi over 4 in there as well, and 3 pi over 4. The tangent of 3 pi over 4 is negative 1, and then we'll also include pi in there. And the tangent of pi is going to be 0. And so these are going to be our points that we're going to use for tangent. We can't go all the way to 2 pi using our quadrantal angles. We just won't have enough information to be able to graph it if we use that. And so it'll make our problem a little bit harder if we don't use pi over 4 and 3 pi over 4. Cotangent will be done similarly. We'll use pi over 4 and 3 pi over 4 for it as well, and also 0 and pi over 2 and pi. So these are actually the correct values that we'll use for cotangent. I'll only do one of these. Oh, there's a secant one. Let's save that one for tomorrow because that's a pretty hard one. Let's go ahead and do this cotangent one. So that one's a little bit different. If I were you, I'd go ahead and pause, do as much of this as you can, and then unpause and see how well you did. So for your transformations, we'll start there. Okay. Since cotan is our parent function, remember we're going to use some of the quadrantal angles. We'll use 0, pi over 2, and pi. But we won't go all the way to 2 pi. We're actually going to use the 2 in the middle that bisects this, which is pi over 4 and 3 pi over 4. Cotangent, if you remember, is the same as x over y when you're on a unit circle. So if I start at 0, the point here is 1 comma 0. So if I do x, which is 0 divided by 1, that'll be 0. If I go to pi over 4, which is right here, my point is root 2 over 2 comma root 2 over 2, which if I do the cotangent of that, x over y, I'll get 1. Going straight up, my point is 0 comma 1. X over y would be, oh, I so did this wrong. Please excuse me, I'm so sorry. I'm doing x over y for 0. So if I do 1 over 0, this is actually undefined. So this will be where your first vertical asymptote is. So I apologize about that. It's this one that you'll get x over y, which is 0 over 1. That's what the one that gives you 0. I'm sorry. If you come over here into the second quadrant, you'll use 3 pi over 4. You'll use the same exact point, so it's going to be 1 again, but because you're in the second quadrant, you'll have a negative 1. And when you get over here to pi, you're going to have negative 1 comma 0 for your point. If you do x over y, you have another vertical asymptote, so you have another undefined. Okay, so now to create these transformations and make them work, to go right pi, I need to add pi to my x. To go up 1, I'll add 1 to my y, and to vertically stretch it by 2, I'll double all of my y values. Okay, so I'll start doing that for this one. Pi over 4 plus pi is 5 pi over 4. Pi over 2 plus pi is 3 pi over 2. 3 pi over 4 plus pi is 7 pi over 4. And pi plus pi is 2 pi. Vertical asymptotes, I can't double them and add 1, so those will remain in the same spots they already were on the first and fifth lines. 2 times 1 is 2 plus 1 is 3. 0 times 2 is 0 plus 1 is 1. And negative 1 times 2 is negative 2 plus 1 is negative 1. So I'll go to pi. I'll create my first vertical asymptote. I'll go to 2 pi to create my next vertical asymptote. And this would be 5 pi over 4. This would be 3 pi over 2, which is the same thing as 6 pi over 4. And this would be 7 pi over 4. So we'll plot those points. We'll connect the dots. And you have one version of your cotan. Let's do this again to get more of them. So if I continue the same pattern, you'll notice that these vertical asymptotes are again pi units apart. So the next one will be at 0, and then from there negative pi and negative 2 pi. You'll take these points and simply transfer them over here directly in the middle. You're going to have a value at y equals 1. To the right, pi over 4, you'll have a value at negative 1 for the y value. And to the left of the center by pi over 4, go left 1, and you'll have a value at 3. So you'll take this graph and make another cubic type function that looks like this. And you would continue that same pattern here and here as well. Okay? You'll notice for each of these we did not find the amplitude, period, and phase shift. We'll talk about those tomorrow, since I didn't do those in any of the examples. Again, example 5 will just be left as well for tomorrow because it's a bit harder. Okay? And that'll be all for these examples for section 4.4 and 4.5 and 4.6.